Hello, today we are looking at applying the rectangle method for area. And you can see here I have a rectangle. And in this rectangle, to find the area, one strategy could be to just number the boxes. Count how many boxes are on the inside. Because as a reminder, the area is the inside of a shape and the perimeter is the outside. It's the distance around the outside edges, kind of like a fence. So with this method, counting the squares, I get 10 centimeters squared, which works very nicely. Now with my same rectangle, another way to solve this problem would be I could count the lengths of the side. And this would be, it's 2 across, and it's, I like to put the little marks in there for my students because it helps out, and I label it like it's a number line. Now it doesn't seem necessary yet, but it will as the questions get a little more intense. So this side is 5, and this side is 2. So the area formula, area equals base times height, or area equals length times width. Both formulas are the same. They mean the same thing. And we multiply 5 times 2 is 10 centimeters squared. Very nice. So now let's move over and look at our triangle. As I go to count the squares in this triangle, I notice there's kind of a problem. There's not too many full squares, and it looks like it's going to be a lot of guesswork. So I'm actually at this point going to skip counting the squares, and I'm going to rack my brain for another option. So if I look back here, I could label my lengths of my sides. All right, 0, 1, 2. So my base looks to be 2 centimeters, and my height, I go through and label those, 0, 1, 2, 3, 4, 5. And it's 5 centimeters, so my height is 5 centimeters tall. Now what I notice, I just picked up on this. If you look, these numbers sound familiar, and if you look back to my rectangle that I just worked on, this rectangle right here, you will notice that the height is also 5 and the base is also 2. So what I'm able to do is, if I draw that line through, it looks like here is the triangle that I'm trying to figure out. So if I use what I know about rectangles and my formula, it looks like I can start to steal a bit of this formula to use for my triangle. So I'm going to use area equals base times height, but there's one issue. Base times height would be if it's a full rectangle. I do not have a full rectangle with this triangle. I have half of the rectangle. I'm going to use that half in my formula, and I'm going to switch the color, divide that rectangle by 2. So to add some color to my formula, I use blue for my rectangles, so this is the rectangle part of my formula, and I must remember to divide by 2. Now I realize using a formula does get away from the rectangular method a little bit, but sometimes we're faced with area problems and we don't have graph paper, or we don't have enough space to come back to our picture here and put in my dotted lines to make my rectangle method and then divide it by 2. So one thing that I will use just to help double check and make sure that we are able to find the area of a triangle is this formula right here. So this is area of a triangle. And again, the area of a triangle is base times height, and then you divide it by 2. You must always remember to divide a triangle by 2. Now I came up with 2 new rectangles. Now this rectangle, you'll notice my first one here, I did go ahead and count out the boxes. So it looks like when I counted through, I had my whole boxes, I labeled those with black. So 1, 2, 3, 4, 5, 6, 7, and 8. And then what I started to do is this was a half, and I know that a half and a half equals another one. So these 2 give me my 9th box or square, and these 2 make up a 10th, and these 2 make up an 11th. And then I had this little one up here in the corner, and that is 1/4. So I get an answer, it looks like, of 11 1/4 centimeters squared, or 11 and 2,500 centimeters squared. So that would be one way to do that. Okay, we could count the squares, or we could start to determine the width and the length, or the base and the height, to find out. So again, I'm going to use that number line idea. So I like to trace this. So this would be my 0, 1, 2. My 3 would be this next line, so it looks like my number is actually in the middle, which is 2.5. And then I count up the top here. We have 0, 1, 2, 3, 4. 5's going to be up here, and it looks like, again, I'm halfway through. So I am at 4.5. So using what I know about my formula, it looks like my base is 2.5 and my height is 4.5. So area equals base times height. So we do 2.5 times 4.5 equals a question mark. Does equal the same 11 1/4 or 11.25 centimeters squared. Don't forget, we need our centimeters squared for our label for our area problem. And then I look at my next triangle here, and I look at my base. I do that number line because that helps me figure this out. And my drawing's not perfect here, but it looks like, again, I'm at 2.5, or that's what I attempted to show, was 2.5. And then my height, I went up, 0, 1, 2, 3, 4, well, 4.5. So again, and I did do this on purpose, it looks like we have the same dimensions, 2.5 by 4.5, as we did over here. Okay, so what I'm able to do is, if I come in and draw this triangle, I kind of, or attempted to, have the same triangle as I have over here in the green. So what you should notice is this triangle and this triangle would be the exact same. So if I take this triangle, would be half of this rectangle, so I can take this answer, 11.25, and divide it by 2. So if I write that, and I divide it by 2, because my triangle is half of that rectangle, it gives me the answer of 5.625, or 5 and 625 thousandths centimeters squared. So I could use that rectangle. This is the official the rectangle method of area model, to come up with this answer. I took my rectangle area and I divided it by 2 to get my answer. I could show my work another way. I could use the area formula, where I do my base, 2.5, times my height, 4.5. Don't forget to divide it by 2 because it's a triangle. And that answer would also equal 5 and 625 thousandths centimeters squared. So it's the same thing. It's just one way it shows you with the formula for the area of a triangle, which is down here. And this is where I use the rectangle method for area, where I took my rectangle's area and I divided it by 2, because a triangle is half of a rectangle. And there are several options that you could do if you come in contact with a trapezoid like this one. You could do one of two methods. You can see how I split it up. One method you could choose to do would be to split it in half and kind of dissect it and figure out the area of this side, do the area of the rectangle, and we could find the area of the triangle and add them together to find our answer. That would be one option. The other option would be to extend that trapezoid and turn it into a big rectangle, which would have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we can multiply those using the area formula. Area equals B times H. We do 6 times 11 equals 66 centimeters squared. But wait, the original shape was not that full thing. We need to divide that by 2 because I added that whole second section to be able to do this rectangular trick. And I get 66 divided by 2 equals 33 centimeters squared. And if you go back and do the area of the rectangle and add it to the area of the triangle, you will also find that you get 33 centimeters squared. And for my students here, I would like you to try these. I need you to find the length of the sides and calculate the area of each shape. Again, you may use the area model if you find the rectangle method of area for the rectangle and you'd like to use that to find the area of the triangle, that's fine. Or if you'd like to do them separate, that would be okay too.